If an aerospace engineer is calculating the trajectory of a satellite,
Right.
and, their math is off by just 0.0014.
Yeah, that satellite does not gently settle into orbit.
Exactly. It burns up in the atmosphere.
Yeah.
Or skips off into deep space entirely.
It's binary. You either balance the equation or you failed.
Right. In applied math, a gap like that is literally a fatal error. But what if I told you that in a completely different branch of theoretical math, being off by exactly 0.0014 isn't a mistake at all?
Yeah, what if that tiny, annoying little discrepancy is actually the discovery of a hidden structural wall in the universe?
Welcome, everyone. We are so glad you are joining us for today's deep dive. We're jumping straight into a phenomenally deep pool today.
Oh, we really are. It's fascinating stuff.
We're looking at a 2026 paper by Philip Lilien. He's out of the UCTE Foundation. And the title is, let me check my notes, Harmonic Condensation, Zeta Curvature, and the Euler Gap.
Catchy title, right?
Right. And we have a massive stack of sources for you guys to pull from. We have the paper itself, obviously.
We have those really extensive excerpts from the, what he calls the Unified Coherence Closure Framework.
The UCCF, yeah.
And, man, the visual appendix, it is just packed with data tables, equations, dimensional maps. It's dense.
It is dense. But our mission today is to understand how this framework connects, three completely different mathematical universes.
Right, the geometry of circles, the infinite fractions of the Riemann zeta function, and
Euler's number, the exponential growth side of things.
Exactly. And doing that requires us to start at the absolute foundation. I mean, before we can talk about circles or infinite series, the Unified Coherence Closure Framework demands that we just completely dismantle and redefine the single most basic concept in human logic.
Which is?
The number one.
Oh, man. I am so glad we are starting here because when I first read the source material, this stopped me in my tracks.
It's a trip, isn't it?
It really is because, in everyday life, unity is just the number one. It's a noun.
Right. One apple.
Yeah, a single apple on a table or a $1 bill. It's just a static quantity. But Lillien's framework describes unity not as a quantity, but as a structural condition.
Yes, a structural condition.
Walk me through that, because it sounds like we are turning a number into a state of being.
That is the exact philosophical shift you have to make to grasp this paper. I mean, think about what a number is in standard arithmetic.
Right.
It's just a static endpoint. 5 minus 4 is 1. The math is just the delivery mechanism to get you to the noun, to the number one.
Right.
But the UCCF completely inverts this. It treats unity as the ultimate manifestation of closure.
Closure.
Yeah. It is the condition that appears whenever, basically, multiplicity has been completely resolved.
Give me a tangible example of that, because multiplicity being resolved sounds a bit abstract. What does that actually look like?
Okay, consider a spinning top.
A top.
Right.
Like the toy.
Yeah. When it's wobbling and rotating wildly all over the table, it exists in a state of multiplicity.
Right.
It's occupying countless different vectors and angles at every millisecond.
Right. It's everywhere at once, mathematically speaking.
Exactly. But when it finally expends all its kinetic energy and it comes to that perfect motionless rest.
Standing perfectly upright.
Right. It has achieved a state of closure. The chaotic multiplicity has resolved into a singular, stable condition.
Oh, wow. Okay.
So the framework argues that the number one is just the symbolic marker of that completed relation. It's what happens when a rotation completes its cycle, or when an excess amount of energy is entirely exhausted.
So if I'm tracking with this, one is less of a thing and more of a result. It's the condition of a system that has finally found its ultimate balance point.
You nailed it. It is the mathematical signature of stability.
Okay, I love that.
And the central thesis of Lillien's paper is that there are two distinct classic mathematical relations that provide pathways to arrive at this condition of unity.
Two different pathways to the same state of closure.
Exactly. Two universal mechanisms. They're called the dimensional rotation seed and the zeta terminal relation.
And see, this is where I actually struggled a bit with the premise. Because if both pathways end up at the exact same destination, the number one, why does the framework care so much about the journey?
What do you mean?
Well, if I take a train to New York, or if I fly to New York, the end result is identical. My physical location is New York.
Right.
Standard arithmetic doesn't care how you get to 1. The cosine of 0 is 1. 2 divided by 2 is 1. We just write the equal sign and, move on. So why does Lilien dedicate an entire framework to the how?
Because your analogy assumes that the destination is just a point on a map.
Isn't it?
No, because if unity is a structural condition, a state of physical or mathematical being, then the mechanism of arrival actually dictates the fundamental laws of reality for that state.
Okay, you're going to have to unpack that for me.
Let's suggest your travel analogy.
Great.
Imagine the destination isn't a city. Imagine the destination is a state of silence.
Little acoustic silence. Got it.
Right. So, pathway 1. You are in a brightly lit, super noisy room.
Yeah.
And you simply reach over and flip the master power switch.
Boom. Instant darkness. Instant silence.
Exactly. The speakers cut out immediately. The silence is achieved through a single, exact, instantaneous physical action.
Okay, that makes sense. What's pathway 2?
Pathway 2.
Yeah.
You are standing in a massive canyon, and you shout.
And the echo bounces back?
Right. Slightly quieter, then it bounces again, even quieter. The sound waves lose energy, decaying infinitely into the atmosphere until eventually...
Eventually, they're so microscopic they effectively vanish.
Exactly, leaving you in total silence.
Oh, I see. In both scenarios, I am eventually sitting in total silence. I am at the number 1.
But the physics of how you arrived there
are completely different. One was a closed, exact circuit being broken. The other was an infinite, gradual suppression of energy.
And that is exactly what the UCCS is mapping. The dimensional rotation seed is the flip of the switch. It is immediate, exact, and geometric.
While the zeta terminal relation is the canyon echo.
Exactly. Infinite, harmonic, and suppressive. They represent 2 fundamentally different logical layers of the universe.
Okay, wow.
And the paper argues that if we can understand the boundary where those 2 layers interact, we can discover something profound about how reality is structured.
Well, okay, let's unpack this. Let's dive right into that first pathway. The flip of the switch, the dimensional rotation seed.
Let's do it.
The paper defines this using a variation of what is, arguably the most famous equation in all of math Euler's identity.
Right.
But it writes it very specifically as negative e to the power of I times pi equals 1. Or mathematically, negative e to the I pi equals 1.
It is a critical equation to dissect.
Huh.
But we have to understand what it means in standard math first.
Right, because anyone listening who took calculus is probably screaming at their device right now. They're like, you wrote it wrong.
Oh, for sure. Standard Euler's identity is usually presented as e to the I pi plus 1 equals 0, or e to the I pi equals negative 1.
Exactly. So why the chain?
Yeah. And see why the UCCF rearranges it. We have to look at the complex plane. When we raise that transcendental number e to an imaginary power like I times pi.
We're not doing simple exponential growth anymore, right?
No, we are dealing with rotation.
Geometry on a graph?
Exactly. Imagine a graph where the horizontal axis is your standard real numbers, 1, 2, 3, but the vertical axis is imaginary numbers, 1i, 2i, 3i.
Okay, got the mental picture.
If you start at the number 1 on the horizontal axis and you apply the function e to the I theta, you actually begin to draw a circle around the center of the graph.
And the value of theta dictates how far you rotate along that circle.
Exactly.
So if theta is pi, and pi represents a half circle in radians, which is 180 degrees, you trace the circle perfectly from the positive side of the graph all the way over to the negative side.
Which lands you exactly on negative 1. This is why standard Euler's identity states that e to the I pi equals negative 1. It's basically a mathematical sentence that says exponential phase rotation through a half circle reaches maximal opposition.
Maximal opposition. It takes you to the absolute furthest point from where you started.
Right.
Okay, so that's standard math. But as we said, the paper doesn't use e to the I pi equals negative 1. It multiplies both sides by a negative.
Yes, it does.
It adds a negative sign to the front of the Euler term, making it negative e to the I pi, and then flips the negative 1 to a positive 1.
Right.
Why perform that specific algebraic manipulation? I mean, what does moving that negative sign actually accomplish conceptually?
It completely changes the focus of the equation from cancellation to restoration.
Restorative.
Think about the standard version. E to the I pi plus 1 equals 0. The sentence is focused on annihilation. It says, if I take maximal opposition and add unity, I get nothing. 0.
And the framework rejects 0.
Exactly. The framework rejects 0 as the focal point. It wants to focus on unity.
Because unity is the condition of closure.
Yes. Or, to avoid just violently agreeing with you. Because unity is the only stable metric of a completed system.
Right, right.
By writing it as negative e to the I pi equals 1, the framework is utilizing the negative sign as a function of inversion.
Inversion, like flipping a mirror.
Yeah. Let's read the UCCF equation like a sentence from left to right.
Okay.
The e raised to the imaginary power represents the action of rotation. The pi dictates that the rotation goes to maximal opposition.
And then the negative sign at the very front.
That negative sign inverts that maximal opposition.
Oh, so it's saying perform a rotation to the exact opposite side of the universe and then instantly invert that state, which just snaps you right back to your starting point, back to +1.
Yes. The paper actually refers to this as a compact grammar of rotational return. It dynamically performs unity through motion.
That's beautifully put.
And the crucial element here, going back to your switch analogy from earlier, is that it is instantaneous and exact.
Yeah. There is no trailing decimal. There is no waiting for the echo to fade.
None whatsoever. There's no limiting process involved. There is no asymptotic tail to measure.
The closure happens immediately.
The very moment the rotation and inversion are logically complete, you basically condense exponential structure, imaginary geometry, and phase inversion into a single perfectly closed loop. You are exactly instantaneously one.
Wow. And this is why the framework classifies it as a primary seed equation. It's a foundational, unbroken law.
Exactly.
Okay, that paints a very clear picture of the first pathway. We achieve unity through exact geometric rotation. So now let's look at the second pathway, which seems to operate by a completely alien set of rules.
The Zeta terminal relation.
Right, the canyon echo. The equation for this pathway is the limit as s approaches infinity of the Riemann zeta function equals 1. So limit s to infinity of zeta of s equals 1.
Right.
Let's break down the Riemann zeta function for, a listener who might not have taken advanced number theory in college. We are specifically looking at this function when the input s is a real number greater than 1.
Well, the zeta function is, at its core, just an infinite series. It's a way of adding up an endless sequence of fractions.
Okay.
For a real number s greater than 1, the function is defined as 1 plus 1 over 2 to the s plus 1 over 3 to the s plus 1 over 4 to the s, continuing to infinity.
So if I plug in the number 2 for s, the series is 1 plus 1 over 2 squared, which is 1/4.
Right.
Plus 1 over 3 squared, which is 1/9, and so on. It's just a massive, never-ending string of addition.
Exactly. Now notice the architecture of that series. What is the very first term?
The first term is just the number 1.
Right. And every single term that comes after it, the 1 over 2 to the s, the 1 over 3 to the s, they're all positive fractions.
So no matter what finite number you plug in for s, as long as it's greater than 1, the total sum must be greater than 1.
Because you're starting with 1 and continually adding weight to it.
Okay, and this is where the paper introduces a specific term that I found incredibly helpful. It actually decomposes the zeta function into 2 parts. It writes it as zeta of s equals 1 plus epsilon sub s.
Yes, that epsilon represents everything that comes after the number 1.
All the fractions.
Right. It's the entire infinite string of fractions condensed into a single variable. The framework calls this epsilon the residual harmonic excess.
Residual harmonic excess. I love that phrase. It sounds almost musical, like a lingering overtone when you strike a piano key.
That's a great way to think about it.
The 1 is the pure note, and the epsilon is the vibration of the wood and the strings carrying on afterward.
The musical analogy is mathematically spot on because these fractions are derived from a harmonic series.
Oh, right.
Now, let's look at the behavior of this excess. What happens to that residual harmonic excess as we push the input value, s, higher and higher?
Well, s is an exponent in the denominator. So if s is a massive number, say 1,000,000, then our second term is 1 over 2 to the power of 1,000,000.
Which is
an infinitesimally small fraction. It's practically 0.
And the third term, 1 over 3 to the power of 1,000,000, is even smaller. As scales toward infinity, every single fraction in that harmonic tail just gets crushed.
The larger tail gets, the faster the tail shrinks. The paper describes this as progressive suppression.
Progressive suppression, exactly.
I was actually trying to visualize this progressive suppression earlier, and I kept coming back to audio engineering.
Oh, really? How so?
Have you ever seen a producer use a noise gate on a vocal track?
I'm familiar with the concept, but let's map it to the math. How does it fit the zeta function?
Okay, imagine you record a singer in a slightly noisy room. The pure vocal recording you want, that is the number 1. But the microphone is highly sensitive. It picks up the air conditioning and picks up the hum of the computer, the traffic outside. That background noise is the infinite series of fractions. It's the residual harmonic excess trailing behind the vocal.
The epsilon.
Exactly. Now, a noise gate is a piece of software with a threshold dial. As you turn the dial up, which in our math is increasing the value of less toward infinity, the software starts brutally suppressing the the quietest sounds.
I see where you're going with this.
First, the distant traffic vanishes. You turn it higher, the computer hum vanishes. The higher you crank that dial, the more aggressive the suppression.
Right.
If you could theoretically turn that dial all the way to infinity, the software would perfectly asymptotically extinguish every single microscopic decibel of background noise. The residual harmonic excess would become absolute zero.
And what remains when the suppression is absolute?
The pure vocal track, the number one, it was there the whole time, just buried under the excess.
The noise gate is a phenomenal way to understand this, but I have to add one critical mathematical caveat.
Okay, hit me.
In a recording studio, an audio engineer is filtering out external physical sound waves that shouldn't be there. They are removing a mistake.
True.
But in the Zeta function, the noise, those harmonic fractions, they are not a mistake. They are a fundamental property of the integers themselves. The excess is an inherent structural reality of how numbers relate to one another.
Oh, that's deep. So the suppression isn't fixing an error, it's revealing a deeper layer of structure.
Exactly, and it highlights the stark contrast between this pathway and the rotation seed.
Because the rotation seed dynamically creates unity through action.
Right, but in the Zeta pathway, unity was already sitting there as the very first term.
Oh, wow. Yeah.
The limit, as approaches infinity, doesn't build the number one. It merely strips away the harmonic multiplicity until only unity is left.
Which is why the paper explicitly classifies the zeta terminal relation as derivative in status. It isn't a primary seed. It is asymptotic, harmonic, and suppressive.
Correct. So we're left with two distinct pillars of closure.
Let's summarize them.
On the geometric side, we have instantaneous rotational return, negative e to the I pi equals 1. On the harmonic side, we have the infinite suppression of excess. The limit, as S, approaches infinity of zeta of S equals 1.
And both mechanisms resolve into the exact same invariant terminal value of 1. They both end up in total silence.
But the laws governing how they achieve that silence are completely isolated from one another. They operate in separate mathematical rooms, so to speak.
And the entire purpose of Lilien's paper is to find out if there is a door between those rooms.
Exactly. How do the rotating geometry of circles and the infinite fractions of the harmonic series interact?
Which brings us to the most difficult and, frankly, the most bizarre concept in the paper.
The search for a bridge?
The search for a bridge. Because to connect these two universes, the author looks for a very specific alignment. It's called the curvature excess zeta level, mathematically denoted as kappa zeta pi.
Kappa zeta pi. To build this bridge, Lilien isolates the excess from both mathematical regimes. We already established the harmonic excess. For any finite value of S, the zeta function produces a value greater than 1. That leftover decimal is the harmonic excess, defined simply as zeta of S minus 1.
Right, that's the leftover noise from the infinite series. Now we need the geometric equivalent, the leftover noise from circles.
Exactly. So we look at the transcendental constant pi. Pi defines the relationship between a circle's circumference and its diameter. It's approximately 3.14159.
Right.
The paper defines the curvature excess as the specific amount by which pi exceeds the nearest baseline integer, which is 3.
So the curvature excess is simply pi minus 3. Which is roughly 0.14159.
Right. Now, Lilien poses a structural question. Is there a specific point in the universe, a specific value of S on the zeta curve, where the mathematical noise of the infinite series perfectly equals the geometric noise of a circle?
Where the harmonic excess exactly matches the curvature excess.
Yes.
Now, I need to push back on this a bit, because when I read this in the source material, it felt almost numerological.
Numerological? How so?
Well, just because I can mathematically set two things equal to each other doesn't mean it means anything in reality, you know?
Yeah.
I can set my body weight equal to the speed limit of a highway and calculate a variable to make that equation balance.
Yeah.
But it doesn't give me any structural insight into the universe. Why does setting the leftover fractions of zeta equal to the leftover decimals of pi create a lawful bridge? Why isn't it just a parlor trick?
That is a vital skepticism.
Yeah.
Honestly, if we were just mashing random formulas together, it would absolutely be numerology.
Right.
But we have to look at what pi and the zeta function represent at a foundational level. Both of them represent the failure of simple integers to contain natural phenomena.
The failure of integers. Explain that.
Well, you cannot build a perfect circle using only straight integer blocks.
Right.
A circle bends continuously. It just transcends basic algebraic counting. That bending leaves a residual trace, the infinite decimals of pi. Similarly, you cannot map the distribution of prime numbers or harmonic frequencies using only static, isolated integers. They bleed into infinite series, leaving the residual trace of the zeta function.
Oh. So both excesses are footprints. They're the tracks left behind when the physical universe refuses to be boxed into whole numbers.
Precisely. By setting them equal to one another, Lilien isn't just matching random numbers.
He's asking a deeper question.
Right. He is asking, is there a specific resonant frequency where the harmonic bleeding of the integers perfectly aligns with the geometric bending of space? Is there a coordinate where the two different types of failure perfectly mirror one another?
Wow. Okay. I admit that completely changes how I view the equation. It's a search for an underlying shared architecture.
Exactly.
So mathematically, the equation to find this coordinate is zeta of kappa zeta pi minus 1 equals pi minus 3.
Right.
Or, simply adding 1 to both sides gives us the core defining formula of the bridge. Zeta of kappa zeta pi equals pi minus 2.
And because the zeta function is continuous and decreasing for real numbers greater than 1, and because the value of pi minus 2 falls squarely within its output range.
There has to be a solution.
Right. There is a guaranteed, mathematically exact, unique, real solution for this coordinate.
And that solution is kappa zeta pi. I'm actually looking at the data tables in the appendix for the numerical value of this bridge, and it is just absurd.
It's a long one.
It's not a clean number at all. It's approximately 3.37699626638162531 and it just keeps going.
It does.
It looks like absolute chaotic noise. How can a string of chaotic decimals act as a perfect structural bridge?
Well, it only looks chaotic because you are reading it in base 10 arithmetic, which is basically a human invention for counting on our fingers.
Fair point.
In the language of pure logic, it isn't chaotic at all. It is a highly specific, anchored coordinate. I mean, just because the square root of 2 looks messy as a decimal doesn't mean it isn't the exact perfect diagonal of a unit square.
Ah, that makes sense.
Kappa zeta pi is the exact geometric harmonic diagonal.
Okay, so we have established this bridge. We have found the unique level on the zeta ladder where harmonics and curvature lock together. Roughly 3.377.
Yes.
What does the framework actually do with this bridge?
Here's where we initiate what the paper calls the harmonic-geometric reduction. Having established a formal link between pi and the zeta function, Lilien basically feeds this link into a wider algebraic expression to see where it leads.
Okay, here's where it gets really interesting. Let's walk through the math on this because it leads us directly to the massive anomaly at the heart of this paper.
Let's do it.
We start with our bridge equation. Zeta of kappa zeta pi equals pi minus 2.
First, let's isolate pi. If we simply add 2 to both sides, we get a new definition for pi based entirely on the zeta function. Pi equals zeta of kappa zeta pi plus 2.
Simple enough. We have effectively translated pi into the language of harmonics.
Now, the paper introduces a basic linear geometric expression, 9 minus 2 pi.
Where does that come from?
In the broader context of dimensional geometry, expressions like this are often used to define curvature boundaries. But for our purposes right now, we just need to execute the algebra. Let's take that expression, 9 minus 2 pi, and substitute our new harmonic definition of pi into it.
Okay, let me write some mentally. So everywhere there is a pi, we plug in the quantity zeta of kappa zeta pi plus 2.
Right.
So the expression 9 minus 2 pi becomes 9 minus 2 times, in parentheses, zeta of kappa zeta pi plus 2.
Exactly. Now walk through the distribution. What happens to the constants?
Well, you distribute the negative 2 into the parentheses. That gives us negative 2 is zeta of kappa zeta pi, and then negative 2 times positive 2 is negative 4.
What?
So we have 9 minus 4 minus 2 zeta of kappa zeta pi. The constants combine. 9 minus 4 is 5. So the entire expression reduces down to 5 minus 2 zeta of kappa zeta pi.
And boom, you have just derived the central identity of the reduction sequence. 5 minus 2 zeta of kappa zeta pi equals 9 minus 2 pi.
Wow.
Look at what this equation represents structurally.
Let's see. On the left side, we have an expression built entirely out of the zeta function. It belongs completely to the harmonic regime.
Yes.
And on the right side, we have an expression built entirely out of pi. It belongs to the geometric regime.
But because we used our bridge kappa zeta pi, they are locked into exact absolute equality.
We have successfully woven the two isolated rooms together.
We have.
Yeah.
But the profound discovery of the paper isn't just that this equation exists.
It's the number, isn't it?
It is what happens when you calculate the numerical value of this reduction. Let's calculate the real value of 9 minus 2 pi.
Okay, let me pull up the numbers. Pi is roughly 3.14159. If I multiply that by 2, I get roughly 6.28318.
Right.
Now I take 9 and subtract 6.283. Let me refer back to the exact tables here. The output value of 9 minus 2 pi is 2.716814692804138.
Stop right there. Look closely at that first portion, 2.7168. Let that number sit in your mind for a second. In the context of foundational mathematical constants, what does that scream to you?
It screams Euler's number, the constant e.
Exactly, the base of the natural logarithm.
But it's wrong. I mean, Euler's number e is approximately 2.71828. This calculation gave us 2.7168.
Very close.
They match perfectly out to the first two decimal places, 2.71, and then they diverge. It is agonizingly close. It is off by a tiny fraction of a percent.
And this brings us to the crux of the entire deep dive. How do we interpret this near miss?
Well, I mean...
Because if you hand this to a standard mathematician, their immediate reaction is to dismiss it. They will say, look, 2.7168 is not 2.7182. They're different numbers.
Right. They'd say you tried to find a convoluted formula to calculate E using pi and zeta, and you just failed.
Exactly. It's a coincidence of base 10 arithmetic. Go back to the drawing board.
Yeah, it feels like a parlor trick that just fell apart at the last second. It feels like an approximation that didn't quite have enough juice to get over the finish line.
But the unified coherence closure framework completely rejects that instinct. It basically validates the tension you feel, the frustration of the near miss, but it pivots the philosophical interpretation 180 degrees.
Oh, really?
The framework argues that the formula didn't fail to reach E. It explicitly and lawfully stopped just short of E. The failure of equality isn't an error in the calculation. It is a measurement of the boundary between two realities.
Wait, so the failure is the feature, the gap is the point?
Exactly. Or rather, the gap is the formal structure that allows the different regimes of math to exist without collapsing into one another.
Man, that's wild.
And this numerical failure equality actually has a formal name in Lilien's paper. It is the Euler gap.
The Euler gap. Delta E. So let's define it mathematically. It is simply the difference between the true transcendental constant E and our geometric reduction formula. So delta E equals E minus the quantity 9 minus 2 pi.
Which, if you distribute the negative, simplifies to delta E equals E plus 2 pi minus 9.
And what is the precise numerical value of this gap?
According to the paper, it is a tiny positive residual value, approximately 0.00146713563863313. 0.00467. With this gap formally defined, the paper can actually write its final grand synthesis equation.
Let's hear it.
Well, we established that our harmonic expression 5 minus 2 zeta of kappa zeta pi is exactly equal to our geometric expression 9 minus 2 pi.
Right.
And we just established that 9 minus 2 pi is equal to E minus the Euler gap.
So you just chain them all together into one massive statement. 5 minus 2 zeta of kappa zeta pi equals E minus delta E.
Yes.
The harmonic side perfectly equals the geometric side, and together they equal the exponential side, minus this tiny little gap.
Exactly. Now, I really want to unpack the phrase the paper uses to describe this gap, because honestly, it is the most important phrase in the entire source text. It calls the Euler gap a lawful residual.
A lawful residual, as opposed to an unlawful error. I'm still trying to wrap my head around how an error can be lawful. What law is it actually upholding?
To understand that, you have to look at the massive differences between the types of math on either side of that equation.
Okay.
We have the harmonic-geometric world on the left, built of pi, and the zeta function. And we have the exponential world on the right, governed by E. These aren't just different numbers. They are entirely different dimensional operating systems.
How so? I mean, pi and E are both transcendental numbers. They both go on forever without repeating. Aren't they cut from the same cloth?
They're both transcendental, sure, but they govern completely different logical behaviors. Pi is the law of contained space. It defines the boundary of a circle. It curves back in on itself.
Right, it's a closed loop.
Exactly. And the zeta function, as we discussed, is the law of harmonic condensation. It suppresses excess to reveal unity. Both of these are systems of closure.
Right, they bring things to an end, a complete circle or a filtered noise gate.
But the constant E is the absolute opposite. E governs continuous, unbridled growth. It is the language of compound interest, of population dynamics, of radioactive decay.
It's explosive.
It dictates how a system pushes outward, changing at a rate proportional to its own current size. The paper calls this the regime of transcendental exponential emergence. Does it close? it emerges.
Oh, I see. So the left side of our equation is the math of wrapping things up, and the right side is the math of blowing things outward. They are philosophically antagonistic to one another.
Precisely. And what the Euler gap proves is that you cannot smoothly transition from a system of closure to a system of emergence. There is no fluid gradient.
There's a hard boundary.
Exactly. You could build a bridge between harmonics and geometry because they both deal with closure. But when you try to use that bridge to reach exponential emergence, you just hit a wall.
Okay, I think I have an analogy for this. Let me see if this tracks with the math.
I'm all ears.
Imagine the mathematical universe is a physical planet. The harmonic-geometric regime, the world of circles and fractions, is the planet's atmosphere.
Okay, I like the spatial mapping. Keep going.
You can build a tower in this atmosphere. You can go higher and higher. The air gets thinner. The temperature changes. But fundamentally, you are still bound by the rules of aerodynamics and air pressure. You are in the atmosphere.
Right.
Now, the exponential regime, the world of E, is outer space. It is a completely different physical environment. There is no air, no friction, different rules of gravity. It is the regime of continuous, unobstructed outward emergence.
A vacuum versus a fluid medium.
Right. Now, our equation, 5 minus 2 zeta of kappa zeta pi.
Right.
That is the tallest possible tower you can physically build using the materials of the atmosphere. It represents the absolute maximum reach of the harmonic geometric world.
And that tower reaches a height of 2.7168.
Exactly. You are standing at the very pinnacle. You look up, and the boundary of outer space, the constant E, is at 2.7182. You are incredibly close. You can practically see the vacuum of space. But you are not in space.
You are still subjected to the laws of the atmosphere.
Right. There is a final tiny distance, a specific mandatory leap you have to make to leave the atmosphere and enter the vacuum. You cannot build the tower any higher because the materials of the tower pi and zeta just cannot exist in a vacuum.
That's a great point.
That final leap, that transition zone of 0.001467, that is the Euler gap. It isn't a mistake in how we built the tower. The tower is perfect. The gap is the structural thickness of the boundary between the sky and space.
That is a brilliant way to conceptualize it. Seriously, the gap is the mandatory phase shift.
Yeah.
You cannot smoothly walk from geometry into exponential growth. You have to jump.
You have to jump.
And the mathematical distance of that jump is exactly 0.001467. By identifying this gap, Lilien hasn't failed to calculate E. He has succeeded in measuring the exact thickness of the wall, separating two foundational laws of logic.
It is genuinely mind-bending. It makes you realize that mathematical formulas aren't just tools for calculating things. They are maps of an invisible logical geography.
Which perfectly brings us to the final major theoretical framework of the paper. Because Lilien doesn't just present these equations and walk away. He organizes them into a structure he calls law layer condensation.
I was actually looking at the visual syntheses provided in the sources for this part, and it looks exactly like a geological cross-section. You see these distinct bands of equations just stacked on top of one another.
The geological visual is highly intentional. The UCCF argues that these mathematical mechanisms don't blend together into a single, muddy, universal formula. They stratify.
They form layers.
Right. They stack upon one another to build the architecture of closure, but each layer maintains its own sovereign rules.
Let's review the strata from top to bottom to tie all of this together.
Okay. Layer 1 is the bedrock, the primary seed. Negative e to the I chi equals 1. This is the law of exact rotational closure. Unity achieved instantaneously through geometric inversion, the flip of the switch.
Right. Immediate, exact dynamic.
Layer 2 sits above it, the derivative law. The limit of zeta of S as S approaches infinity equals 1. This is the law of asymptotic condensation. Unity revealed by the infinite suppression of harmonic multiplicity, the fading echo in the canyon.
Slower, suppressive, infinite.
And layer 3 is the interface layer at the surface, the reduction chain. 5 minus 2 zeta of kappa zeta pi equals E minus delta E.
The interface layer.
Yes. This is the law of curvature excess alignment. It basically demonstrates how the harmonic and geometric laws can intertwine to reach the absolute edge of their domain, arriving precisely at the boundary of exponential emergence, leaving only the lawful residual of the Euler gap.
So they govern different phases of mathematical reality, but they are all united by their relationship to the concept of unity and closure. It is an incredibly cohesive narrative.
It's a breathtaking piece of synthesis, really.
Mm-hmm.
But, as with any theory that attempts to unify disparate pillars of reality, we have to be incredibly careful not to overstate what has actually been accomplished.
Absolutely. The quickest way to ruin a brilliant theoretical framework is to make it promise things it can't deliver. And to his credit, Lilien actually includes a very prominent "what this paper does not claim" section. I really want to go through these guardrails because they are crucial for keeping our feet on the ground.
Let's do it. I'll take the first one.
Hmm.
The paper explicitly states that it does not claim that the zeta function and Euler phase rotation are identical processes at finite values.
Meaning, just because they both ultimately arrive at the number 1, it doesn't mean e to the I pi is secretly doing the same mathematical work as the sum of 1 over n to the s. One is spinning a circle, the other is adding infinitely shrinking fractions. The journeys are completely different, even if the destination is the same.
Correct. We're linking their terminal states, not their operational mechanics. Guardrail number 2. The paper does not claim that kappa zeta pi, our exact bridge coordinate of 3.377, is a recognized standard constant in mainstream physics.
This is an important distinction. You can't open a standard physics textbook tomorrow and expect to find kappa zeta pi listed next to the speed of light or Planck's constant.
Nope, not going to happen.
It is mathematically valid, we can calculate it, but it is a bespoke structural tool built specifically for the geometry of the UCCF. It hasn't been proven to map to, say, the mass of an electron.
Not yet, at least. Its utility in applied physical sciences remains an entirely open question. Now, for the third, and arguably the most important guardrail. The paper definitively does not claim that the expression 9 minus 2 pi equals E exactly.
Yes. If anyone listening takes away just one thing from this deep dive, let it be this. Do not walk into your university math department tomorrow and tell your professor that you found a new exact algebraic formula for E. You haven't.
You really haven't.
The whole point of the framework is that it doesn't equal E. The gap is real. The gap is the entire point.
The approximate equality is a structural precursor pointing toward the boundary. It is not a literal identity. If you erase the gap, you literally destroy the theory.
And the final guardrail. The paper does not claim that this framework represents a new computational theorem in standard mathematical analysis beyond the known, accepted behavior of the zeta function.
Which is to say, Lilien hasn't discovered a new shortcut to calculate the zeta function. And he certainly hasn't solved the Riemann hypothesis. He hasn't altered the raw computations of the math.
He hasn't changed the numbers, he has changed what the numbers mean. He has provided an interpretive synthesis, like a philosophical lens through which we can view the architecture behind the formulas we already know.
That is the perfect way to summarize his contribution. It is a reorientation of perspective.
We have covered an immense, staggering amount of ground today. We started by questioning the very nature of the number 1, turning it from a static noun into a dynamic condition of closure.
We traveled through the instantaneous rotating geometry of the unit circle.
We waded deep into the infinite harmonic noise of the zeta function. We built a mathematical bridge out of curvature and fractions, used it to construct a tower to the very edge of the exponential universe, and measured the exact thickness of the boundary separating those realities.
When you trace the thread from start to finish, the elegance of the logic is just undeniable.
So what does this all mean? If I had to boil down the narrative of Lilien's paper into a single thought, it would be this. Harmonic resonance condenses into unity, rotational phase restores unity exactly, and that tiny, frustrating space left over between geometric reduction and exponential emergence is the Euler gap. It is a feature of the universe's logic, not a bug in human calculation.
It fundamentally reframes our understanding of error, noise, and approximation. It suggests that perfection isn't always found in an exact balance. Sometimes, perfection is found in the precise measurement of an imbalance.
And that idea actually brings us to a final thought for you, the listener, to mull over on your own. A way to take this abstract math and apply its philosophy to the wider world.
Because if a tiny, seemingly chaotic mathematical discrepancy of 0.001467 isn't an error, but rather a lawful residual.
A vital structural boundary.
Right, a boundary separating two completely different foundational regimes of logic. It raises an incredible, almost haunting question about the rest of our sciences.
We spend so much time and billions of dollars in physics, engineering, and data science trying to smooth out our data. We try to force the left side of our equations to match the right side perfectly. But what other tiny errors, what other bits of noise or residual discrepancies in our laboratory measurements or our cosmological models are we currently ignoring or actively trying to erase with better software?
How much of the noise that we blindly filter out in the pursuit of clean data is actually the shadow of a structural boundary? How many Euler gaps are hiding in our current models of quantum mechanics or astrophysics, masking entirely new realities that are just waiting to be discovered?
It makes you wonder, maybe the real magic, the true underlying architecture of the universe, isn't found when the equation balances perfectly. Maybe the real secrets are hiding right there in the gaps.